So welcome to this session about rethinking your data model for improved performance. Some quick introductions about me and my co-presenter. I'll let Lauren introduce himself, but my name's Sean Robinson. I'm the director of data science at Graphable. Graphable is a specialty consulting firm. We specifically work on kind of all things graphs and graph related. So we often say, if you have a graph or you're thinking about building one and you want to do something with it, we can probably help you with that. So anything from schema improvement to graph machine learning or integrating graphs with other systems, we kind of handle all of the above. And then I'll pass it over to Lauren to introduce himself.
Thanks, Sean. Hi, guys. I'm Lauren. I've been around the cryptocurrency space for a while. I'm the founder of Breadcrumbs, and at Breadcrumbs, we provide investigation and monitoring tools for crypto. So some of the questions we help answer with our analytics tools are, where did the money go? Where did the money come from? Who are all these entities involved in these transactions? And some of the main use cases are like law enforcement using us to trace the flow of illicit funds.
Very cool. Can you you can still hear me, Lauren?
Oh yeah.
Okay, great.
Great.
So we'll just do a quick overview of our agenda, and then I'll pass it over to Lauren to kind of talk through some kind of our problem. So we're going to start. We already did introductions. Lauren's going to take us through kind of the main use case that we were looking at. I'll kind of take a walk through the approach we took with Lauren as a client. We'll talk through some of the outcomes from our engagement, and then Lauren will demo some of what we were able to come out with. And then we'll be sure to leave some questions, some time for Q&A at the end. If you have any questions, feel free to put them in the questions section, and we'll get to those at the end. We appreciate anything you guys might want to know. All right, let me see here. So I'm gonna stop. Do you want to go?
We can start. We can start with that. Yeah. I think this is a good way to start with it. So I guess for Breadcrumbs with our company, we have an analytics tool. It's visual. And we've been building this out for, 4.5 years now, constantly iterating on it. Been using Neo4j since the beginning. And there's quite a lot of problems that we deal with, challenges, I'd say. So before meeting Graphable, just to give you some context, like the kind of data we're dealing with is massive. You know, let's say we want to trace some Bitcoin transactions. You know, we need to keep a history of all the Bitcoin transactions in our graph databases, or the relationships anyways. And to give you some context, right now, there's about 7 billion Bitcoin transactions across 700 million Bitcoin addresses. So, you know, you have quite a lot of nodes and quite a lot of relationships that need to be in the system, that need to be indexed. And, you know, this, like, any sort of solution that we have in mind has to keep this, you know, with the realm of how do we deal with all this data. So that's just the first piece of it. And maybe I'll jump into to showing you guys really quickly how it looks, how it works. Okay, yeah, this one here, window. Cool. And I think you guys can see my screen, right?
Yeah.
Yeah, great. So this is kind of how our visualization tool looks and works. Now, keep in mind, how it looks now is how it was before we met Graphable. And generally speaking, when you look up a crypto address, it always starts here at hop 0. Everything to the left are incoming. Everything to the right is outgoing. And you know, we also sort the data, sort the relationships from top to bottom. So most of the funds came from this address. Most of the funds went out to this address. And it's a very easy, simple, but powerful tool for people to use, you know, to start tracing out the money. You can see like how simple it is to see where that money went. And so coming into the situation meeting with Graphable, we had already kind of built this relationship graph system already. But the next step we wanted to do with Breadcrumbs was create a product called Pathfinder. And so the real problem here that we're trying to solve is, as an investigator, I could sit here for hours. I could sit here for days and weeks, constantly clicking out, trying to find, well, what exchange did the money go to? Or where did this money eventually end up? And so we've been working on this product called Pathfinder, which would essentially automate that process. And remind me, Sean, what's there's that function in Cypher, it's called the shortest path, right?
Yeah.
Yeah. So essentially leveraging, the shortest path or other types of Cypher queries like that. But, along with the problem of like massive amounts of data, we have some other issues of, we've already got a schema that's already built into the system. And now we have to add this additional feature, that doesn't break our schema too much, but as well, we're dealing with billions of data points. So piecing all those together, is really, sounds like quite a massive challenge. So yeah, I'll just kind of stop it there. And hopefully that gives you guys an idea around how massive of a problem challenge this is that we're facing.
Very cool. Thanks, Lauren. So after Lauren kind of reached out and we kind of got a sense of what they were looking at, we started to kind of apply what we kind of call like the Graphable's methodology when engaging with anybody, and then kind of the specific methodology we use with Breadcrumbs. So at Graphable, kind of our thesis statement is to delight clients through unusual excellence. And our kind of three unique things that we try to bring to every project is every project is a partnership. We're not really interested in going in and just, fixing some problem and, getting out as soon as possible. We're really interested in investing in our clients and understanding what drives them forward, what brings, what are the things that they are interested in improving as a whole for their company, and kind of supporting that from the ground up. We understand and tenaciously pursue the why. So not just fixing whatever problem we're immediately presented with. We often find that if you dig 2 or 3 problems deep, that's where the why really comes in, and addressing that can be where you get real value. And then we strive for kind of high value, high touch, excellent delivery on all of our clients. So bringing in strong ROI, constant communication, and then bringing that unusual excellence to every client. Specifically with Breadcrumbs, we knew that there were kind of 2 main things that we wanted to approach, because there were a lot of different directions that we could try to solve this problem from. So the 2 main things we went for was pursuit through iteration. There were a lot of different ways we could go. And so for us, it wasn't about picking a single thing, declaring that would be the solution, and then just brute forcing towards it, but to iterate piece by piece, also utilizing Lauren's team, who were doing a lot of the actual boots on the ground work, and giving them the opportunity to iterate through the solutions that we proposed so that they could ultimately arrive at the one that made the most sense. And the second was building confidence through building knowledge. So when we first came in, Breadcrumbs had been using Neo4j for a really long time. But there were definitely some areas where there was some very, very kind of low level systems level mechanics of Neo4j that they were less familiar with. And so for us, it was about building up their knowledge base within their development team, so that when they didn't necessarily need us to, tell them every single little thing to do, we were kind of equipping them so that they could wield that information for themselves to kind of solve their own problems. So a couple things to kind of think about if you want to, when you're kind of approaching redesigning a data model. This is something that is kind of our bread and butter at Graphable, is kind of helping people with their schema design. And one of the things that we always try to convey is be aware of kind of what it takes. There is work that will need to be done. So there you need to be prepared to iterate and have some growing pains and try different things out. The second thing is to be aware that sometimes these iterations can be resource intensive to kind of make the adjustments to not just Neo4j, but potentially architecture that sits around Neo4j. So for example, with breadcrumbs, Neo4j is not their own, like the only thing in their application. There were several other systems that sat around and complemented Neo4j. So some of it was potentially like offloading some of the data from one system and then the other system now needing to adjust it. And that takes effort. And then one of the other things that we did with breadcrumbs was really kind of going through this process of adjusting mindset. So like Lauren was talking about, how at first, a lot of what they were doing was kind of very visually driven. And so their schema was designed from a visual perspective. And one of the things that we came in and kind of introduced them to was this idea of like that visual perspective being a very, very good first draft. But then when you want that really strong performance, you need to think about your schema in terms of computation. And this really varies from problem to problem, but for specifically the functionality they were looking for and given their limitations, we pretty much went all in on pure computational efficiency within their schema, while still maintaining all the existing application functionality that they already had. So then from there, we were also kind of going through this education process and kind of equipping their team. And part of that was really unlearning a lot of ideas that were rooted in RDBMS. This is something that we do a lot with clients, where clients are very familiar with traditional databases. And that was true with a lot of breadcrumbs developers. And so for us, it was, taking, schema decisions and kind of reframing them in a much graphier mindset, when some of them were a little more RDBMS focused. And then the last thing is just kind of taking all of that and then executing that through different iterations to find what works. So there were several times where we talked about, hey, we could try these 3 different things. And, Lauren's team would go, they would try something, they'd say, hey, we don't really feel like that worked. What if we tried this? So what to kind of do when it comes to rebuilding your schema? First thing, get your database in memory. This is probably the #1 thing. I can't stress this enough. You can do all of the fancy stuff you want with query optimization and this, that, and the other thing. But if your database isn't in memory, you're going to be pulling from the disk and it's going to be 10 times slower. And so given where you might have constraints around, the size of a machine or, storage of a data footprint, then that's where you're often making tough decisions about only keeping what matters. So for breadcrumbs, it was also about potentially offloading some of that to other systems, saying, does this really need to be in the graph? Yes or no? And if not, because you're essentially making the decision, do I want to store, if I have limited memory, do I use that to store a string, or do I use that to store more relationships that I'm going to traverse? And go ahead, Lauren.
That piece there. Yeah. See, that was the challenge, is we had so much data. So our ability to choose what to leave in or what to take out was so strained. We really, that was and that came a lot from those iterations. Yeah. Sorry, I cut you off there a bit.
No, absolutely. Feel free to chime in. And I think that gets back to kind of one of our core principles that Lauren and I decided on was, let's let the graph be a graph. So there are plenty of other database systems that store strings really efficiently. Let's let them store the strings. Let's let the graph do what only the graph can do. So specifically in their use case, because Neo4j was supporting like these key like Pathfinder and other traversal based functionalities, like just letting it do its thing, and anything that wasn't specific to graph, put that somewhere else, became a really, really powerful direction to go. And then again, understanding what your options are and that none of them are going to be perfect. That every single, there were many times where we were having conversations to say, well, we could do this, but then you're going to have to do this, which is going to be a ton of work. Or, well, you could do this, but that's going to cost more money. And a lot of that was just about kind of knowing the directions and knowing the pros and cons of each. There's never a perfect solution with these things. And then, so from us, it was really, when it came to equipping their team, kind of coming at this from two different directions. One was kind of that ground up education where, I mean, we were literally, in Zoom and I'm drawing stuff on the screen, explaining how memory allocation works. And then the other side of that is his team actually getting hands-on experience going and applying this stuff. And I think between the two, we got to a place where you guys were really able to go, if I presented you guys 3 ideas, you guys could go try out all 3 and say, this one really, really worked. I don't know if you have anything else on that.
Well, I think it's important to note a few things, like the type of cadence that we had for our meetings, I think was maybe once every couple weeks or once every month.
Yeah.
And, like our background, we're all developers. Like we know how to build cool tech, but we don't know Neo4j. We don't know the ins and outs of Cypher, and the schema design. So, some sort of basic functionality that I guess you would normally learn, like in the early days, if you knew Neo4j, like we just didn't know. But as engineers, we knew where we wanted to go. So yeah, in those conversations, we had, like we sort of communicated our idea of what we wanted to be, and you gave us those options. And then, kind of on a weekend or, a week later, we would try it and be like, oh no, that really didn't work. Or yeah, okay, this is groundbreaking. And so it's really those iterations of eventually would unlock the thing that we wanted to get to.
Yeah, awesome. All right, I'll let Lauren talk about some of the outcomes we were able to get to together.
Cool. So I was like showing the graph, or
yeah, I
through
didn't go through these bullets and just kind of like
okay. Oh yeah, I guess so. So yeah, some of the outcomes that we ended up getting was like our database schema got like reduced by 90%. So that goes back to the what Sean was talking about, only leaving what matters, which helped with keeping things in memory. And of course, that led to things being ridiculously faster. Because the problem was we had tried this like Pathfinder feature that we wanted to get to in the past, like a year ago, 2 years ago. And every time we tried it, it would just take down our server. Like the entire database server would just go down. So reducing the footprint really helped with the speed and keeping everything running properly. Yeah, it would basically be once it was more than 4 degrees of separation. That would also just take down our server, or you wouldn't get a response or anything. But now we got queries like responses, from 4 degrees. Now it's all the way out to 16 degrees of a radius, which is ridiculously huge. And it also, it gave us the ability to do this whole new Pathfinder feature, which, to the user is a significantly impactful feature because it saves hours and days worth of work and time. Should I just get into it and show it, or?
Yeah, let's show them what you guys were able to do.
Show them the final stuff. Okay, great. So what I'll do is I'll first show you the sort of basic one. So the idea is, here's an investigator. Everything to the right is where the money went. As an investigator, you could just sit here for days. I've tried this before.
I think you're showing the session. I think you've got your you're sharing.
Okay.
Oh, there we go. Yep.
We good? Yeah. Okay. So with this one, this one specifically, I could just sit here for days. I've done this before. Like I spent 5 hours once, seeing it eventually goes out to like 10 hops, and there's all these money laundering techniques happening. Or, with the Pathfinder, let's say, we want to get this result here of 5 hops out. What I'm going to do is I'm just going to go back and just start the graph from the beginning, the investigation from the beginning. And this new Pathfinder feature, remember we talked about the shortest path? So now I'm going to say, hey, show me the shortest path from this address, the root address, to the one that we know that's 5 hops out. Okay, so I'm just going to click, that's the destination address that I want. And we have the ability to search within a radius of 16 hops, because now we updated our schema. And this is how powerful this product is. That took what, 3 seconds? Okay, you can see that's pretty ridiculous. And there, it just did all that work for us. So that's just the shortest path one. But you know, like, we kept going with this Pathfinder feature with Graphable, and we're like, okay, great. You know, maybe the investigator won't know like what the destination address is. Maybe instead, what they'll want to be asking is, I'm going to switch to another tab here. Maybe instead, what they want to be asking is, show me all the paths from this root address to a crypto exchange. Because as an investigator, you're like, well, if the money goes onto a crypto exchange, that's actionable. We can send a subpoena there. They can freeze the money. And so the example I'm showing you right now, this is actually the world's largest crypto hack. It was $500 million was stolen from Axie Infinity. And, you know, like, these guys, I'll just kind of quickly wrap it up. But yeah, mostly most of the money went into Tornado Cash. But if you want to answer the question, what exchange did the money go into? Let's just go to Pathfinder here. We could do a closest entity search and just say, hey, show me what entity, show me what exchange, what path went into an exchange. And so the paths you'll end up getting are completely different. And something like this would take you hours to do, days maybe. And there in about 10 seconds, you know, using the, here you go, the money went into Huobi, Crypto.com, Huobi, FTX, Huobi.
So cool.
Yeah. So all of that through our work with Graphable.
Awesome.
Were there any questions, or do we still have more stuff on the?
We've got about I'd say, so let's see, 7 minutes left, so we can definitely spend some
time.
We
do. Questions. Okay, great.
Yeah.
I wasn't sure if I was rushing.
Oh no, you're good. So yeah, we can go through and answer the questions. Let me take a look. I'll take a look at the chat first.
Show us another
tab. They want another one, Lauren. They want another one.
Another one. Okay. Let's see here. Maybe I'll have to share my screen again. Yeah.
Yeah, we can spend we can go through another one for a few minutes, and then I'll leave some time for Q&A at the end.
Okay. So yeah, I mean, this is the main one that's very actionable and useful.
So can you talk a little bit about like the difference between because you're talking about how this might have taken days, like kind of what the difference for the investigator is.
Maybe I'll do that. So I'll undo this. So,
and maybe what Roger asked a good question, which is, who are your customers generally? Government, private investigators, banks?
We have a wide range. So it goes from like, we have retail plans. So individuals like yourselves can just go, and if you're into research or cybersecurity, we have a lot of crypto companies using it to mitigate their risk of exposure to dirty money. We have quite a lot of law enforcement that use it to investigate illicit activities, scams, hacks, you know, a lot of pig butchering scams. Yeah, a lot of, you know, securities violations. There's a lot of illicit activity. And then, yeah, we have a lot of financial institutions as well using it. But the real sort of a competitive advantage that we have is the product is so simple to use. That's really important. And that's why, like, using a lot of the powerful indexing and, you know, Neo4j features really allows us to do that. This whole idea of incoming on the left, outgoing on the right. But what you see here is really just the top 10. You know, the top 10 relationships on each side. But let's just say, you know, you're an investigator, this hack happens. Let's just say you're the one tasked with like, okay, $500 million was stolen. What do we do? Yeah, this is actually how many paths. It's the North Korean government's Lazarus group. They're the hacking group out of North Korea. And so they use a bunch of different patterns to like actually launder the money out. And so you can see it's quite, these are all techniques, you know, the money goes into a bunch of different wallets. It went through a mixer and it gets consolidated. But somewhere in here, yeah, you can see it always goes to Tornado Cash. That's the mixer. Somewhere in here, they actually did send to like 1 or 2 exchanges. So the reason it would just take a long time is you have to sit here and you have to like just click out. Well, did it go to an exchange here? No. Okay. Let's try another one. You know, and so that's kind of why it takes time, and that's why as Pathfinder, it really makes a difference. It can really speed things up. Yeah, does that kind of help answer that question?
Yeah, I think so. We had a question from Meredith, I think is a good one.
Mm-hmm.
Can you give some examples of the data that you ended up removing from the graph as a result of the exercise?
Yeah, I mean, it was more about how we connected our indexes to, we literally just had to redesign the entire schema.
Yeah,
you know, design it in a way.
There's a lot of decorator data that we ended up pulling that were kind of, there were some nice to haves, or we also did a lot of taking what was a node and reducing it to our relationships and kind of collapsing. I think you guys had, you had like a handful of node types, a handful of relationship types. And then
we did, yeah.
And then it was kind of just really simplifying that down. So I think that gets back to that kind of performance first mindset. Let me
Absolutely.
take that Q&A section. Oh, bunch of questions. It sounds like partnering with Katie Ann. It sounds like partnering with Graphable allowed you to really maximize at least the value of breadcrumbs is getting any of it. At what point did you know you needed help with Neo4j implementation, and how did you find and decide on Graphable?
Who was it? We were working with a company before, but I think they had pivoted or something, and they referred us to you guys.
Oh, interesting.
So, yeah, that's how we got connected to you.
Okay.
So it worked out really well, yeah. Because to us as a business, this is now like proprietary technology.
Yeah. Gabriel said, what would be the best way to make sure your graph or part of what you need to read is in memory? I would say that it goes back to some of what we talked about. There's a lot of different directions you can go. I would say be really choosy about what you put in Neo4j. At the end of the day, you have a certain amount of memory, and and the main benefit Neo4j is probably giving you is quickly traversing relationships, right? That's what makes it so powerful over things like RDBMS, is that you don't have to calculate those things at runtime. They're already in memory, and you get to just access them right away via pointers. And so if you are also using it to store things like really long complex strings, or you're using it for other capabilities, all of which are great, and like I love using Neo4j for those functions, but are not unique to Neo4j. They're honestly there for convenience. I would say prioritize, like it goes back to let the graph be a graph. Prioritize the things that only Neo4j can give you, and put anything that's going to enable that into memory. And especially if you're limited on hardware or whatever it is, then you can kind of beef up from there. And so that's what I would say. Let the graph be a graph. Got time for maybe one more. Let me take a quick look at session. Ed asked, how do you load new data? If you want to answer that last 10 seconds here.
How do we load new data for the Pathfinder?
In the graph.
Oh, like our ETL. I mean, that's the other part of the consideration was we had to rebuild like a whole external system. that updates our ETL data into this Neo4j. So we had to build entire new systems around it.
Yeah, awesome, cool. Well, Lauren, thanks for doing this with us. This was super fun. We always
just to
working together.
Close it out. I'll do a quick last one of Pathfinder. Yeah. So this is just same sort of thing. I know it just kind of looks pretty and all. So if we just do another search while we go it out. Yeah, really appreciate you having us come on and sharing our story.
Yeah. Oh, look at that.
There you go.
Beautiful.
Yeah. It's pretty pictures and it's user friendly and fast as hell.
Awesome. Thanks so much. Well, if you guys are interested in what Lauren does, you can find them on it's breadcrumbsapp.com.
Breadcrumbs.app.
Breadcrumbs.app. And then we're at graphable.ai. If you guys are interested, feel free to connect. My information should be somewhere in the thing. Thanks so much. Thank you, everybody.
Thanks, guys.